In this video, I am going to show you how to find all the real zeros of a polynomial function. The rational zero test basically states what rational numbers are possible as zeros, meaning they won't tell you that these are the zeros, they're just saying these are all the possible choices that could be a zero for a function. So for example, what you're going to do is in order to find the possible zeros, it is going to be the plus or minus of all the factors of the constant term, which in this case would be a 6, divided by the factors of the leading coefficient would be 2. So for example, it is going to be plus or minus all of the factors of 6 divided by all of the factors of 2. So it would be plus or minus 6, 3, 2, and 1. Those are all the factors of 6. And the factors of 2 is 2 and 1. So to find all the factors, you would take the first factor and you would basically say, okay, it could be plus or minus 6 over 2, or it could be plus or minus 6 over 1. Then you would take the next number, which is 3. It could be plus or minus 3 over 2, or it could be plus or minus 3 over 1. Then you take 2. It could be plus or minus 2 over 2, or it could be plus or minus 2 over 1. And then the last factor on top, it could be plus or minus 1 over 2, or it could be plus or minus 1 divided by 1. Now in this case, you would clean it all up. For example, 6 divided by 2 is 3. So it could be plus or minus 3. It could be a positive 3 or it could be a negative 3 as a possible zero. It didn't say it is, I'm just saying it could be a possible zero. And then it also could be a 6. The next term is 3 divided by 2, so it could be a possibility of 3 divided by 2. The next number is 3 divided by 1, which is 3. We already have that written, so we don't write it again. The next number is 2 divided by 2, which is plus or minus 1. The next number is plus or minus 2 over 1. We don't have a 2, so it could be plus or minus 2. And then plus or minus 1/2. And then last, it would be plus or minus 1, which we already have written down, so we're not going to write it again. So these are all of the possible factors of this function. And what that means is if we used synthetic division to determine if any number is a factor, we would plug these numbers into the shelf and figure out which one of these numbers will give us a remainder of 0. So let's try it. First, we need to find all the possible zeros. So we know it could be plus or minus 3, the factors of 3, which are 3 and 1, divided by all of the factors of 2. And the factors of 2 are 2 and 1, which means it could be 3/2. It could be plus or minus 3. It could be plus or minus 1/2, or it could be plus or minus 1. We do not know what numbers work, but we do know these are the only possible rational numbers that work, meaning there could be other zeros that could be decimals, square roots. They could even be imaginary numbers, but in order for it to be a rational number, it can only be these possibilities. So to find out what those are, we're going to have to test them. So I always like to start with a whole number or an integer, for example, instead of a fraction. So I'm going to go ahead and start with 3, and let's just see if it works. So the coefficients are 2, 3, negative 8, and 3. Bring down my 2, multiply, I get 6. 3 plus 6 is 9. 3 times 9 is 27. Okay, this is getting really big, so this is probably not going to work. That will give you 19. 3 times 19 is going to be 57. Okay, so that doesn't work. That was not going to give us 0. All right, so 3 didn't work. We could go ahead and try negative 3. So first thing is bring down 2. Negative 3 times 2 is a negative 6. Add to get negative 3. That gives me a positive 9, which gives me 1. Negative 3 times 1 is negative 3. Oh, it worked. So we now know, since our remainder is 0, we know that negative 3 is one of our zeros. Now, the next thing is we need to figure out, could there be any more? Well, you could either go back to the original numbers, but since we got a remainder of 0, we can actually take our answer, the coefficients of our answer, and actually use that in synthetic division. So we know negative 3 worked. We know that a positive 3 didn't work. So I'm going to try 1. If I bring down the 2, I multiply to get 2, bring down, add, and I get negative 1, multiply, get negative 1, and I get 0. Oh, yay, that worked. So we now know another answer, which is 1. At this point, we are down to, remember, the first, after the remainder, the first term is a constant, and the second term is the coefficient in front of x, and then it kept going x squared, x cubed. But at this point, we know that this is 2x minus 1. To find any more zeros, we can actually just take this and set it equal to 0. So I would add 1 to both sides, and then divide by 2, and x equals 1/2. And that's our final answer. So we know that negative 3 worked, we know that 1 worked, and now we know that 1/2 worked. And those are our 3 rational zeros that actually will give you from this function. Meaning if we were to graph this function, we know that it's going to cross the x-axis at negative 3, it'll cross it at 1, and it crosses it at 1/2. So let's find all the real zeros. If we're left with a quadratic, we can either factor it to find the last 2 zeros. If it can't be factored, we're going to use the quadratic formula. Again, negative b plus or minus the square root of b squared minus 4ac all over 2a is our quadratic formula. So quadratic formula is that. So find all the real zeros. Well, we know all the possible zeros are going to meet anything, any factored of 4, which is 4, 2, and 1, divided by the factors of 1. So we're looking for 4, negative 4, 2, negative 2, and 1, negative 1 as our possible shelf. We know that the coefficients are 1, 1, negative 4, and negative 4. So I like the number 1, so I'm going to attempt the number 1 and see if it works. Always bring down 1. I get 1. I get 2. Multiply to give me 2. That adds to give me negative 2. That multiplies to give me negative 2. And that adds to give me a negative 6. It did not work. Positive 1 did not work. So let's try a negative 1. Bring down the 1. That gives me negative 1. That gives me 0. This gives me negative 1 times 0 is 0. This gives me negative 4. And negative 1 times negative 4 is a positive 4. And we got our remainder of 0, which is great. So we know that negative 1 is a 0. Now, at this point, we can either create a new synthetic division and choose another number based off of this, or I can notice that this, if I was to write this out, this is x squared minus 4 because there is no x value because it was 0. At this point, I can actually go ahead and set it equal to 0 because I can solve this equation. I can solve it by adding 4 to both sides, and then I can take the square root of both sides, and I'll get x equals plus or minus, don't forget, when you take the square root, it's plus or minus, I'll get plus or minus 2. So therefore, my final answer is negative 1, a positive 2, and a negative 2. And we're done because there are 3 zeros that we found, and the highest degree is a 3, and that means that there are no more zeros to be looking for. So at this point, again, you could have used synthetic division, meaning if I plugged in 2, I will get 2, and that'll give you 4. That will give me my remainder. And I can, at this point, this is x plus 2 equals 0. So I would solve by subtracting 2. And so x equals 1 negative 2. So I still get the same answers. It just depends at this point, the moment you hit a quadratic, meaning the moment you had 3 numbers, not the remainder, but 3 coefficients, you can actually solve from there using either the quadratic formula or you can factor. X squared minus 4 factors into x minus 2, x plus 2, which again gives us x equals 2, x equals negative 2, which again is how we got the plus or minus 2. Any of those ways will work. So let's try this. Find all the real zeros of this function. Well, first we know it's going to be all the factors of 6, which is 6, 3, 2, and 1, divided by 1. So I'm just going to stick with this. So we are going to figure out what's on the shelf. There is no x squared term, so we got to put a placeholder, negative 7, negative 6. You know what? No, I'm going to stop here. For another example, I would like for you to pause the video and attempt this problem on your own, and then when you're ready to move forward, unpause the video so you can see how I solve this. Now at this point, I would like for you to pause the video to try to do this problem on your own, and when you're ready to move on, go ahead and unpause the video to see how I've worked out to find all the zeros. First, we're looking for all possible zeros. So at this point, I know it's going to be plus or minus 6, 3, 2, and 1 because it's all the factors of the constant. So we're going to do a shelf. It's going to be 1. This would be a 0 because there is no x squared term, so you got to put a placeholder of a 0. Now, I'm going to try to use the number 1 and see if it works. If I plug in 1, I get 1, add, multiply, add, multiply. That gave me a negative 12, so that did not work. So I'm going to try a negative 1. Bring down my 1, multiply, add, multiply, which is not 2. Negative times a negative is a positive 1. Add, multiply, actually turns to a positive 6, so we now have a remainder of 0. Now, at this point, we know negative 1 is one of our answers. At this point, it is a quadratic. Why? Because after the remainder, we have 3 coefficients. Now, at this point, you could either create a new synthetic division, but at this point, I realize that this is x squared minus x minus 6. I can actually factor this into 2 parentheses. It factors into x minus 3, x plus 2. So I can go ahead and solve these factors, and I'll get x equals 3 and x equals a negative 2, and those become my final answers of zeros. You could have done the same thing, taken a number, put it in the shelf to see when you can continue to get a remainder of 0. Now there's also a way to use a calculator to find the zeros. If you pull up a graphing calculator, if you go to y equals, clear out anything that you may have, and I'm going to type in x to the third minus 7x minus 6. And if I hit graph, I want to know my zeros. So what you're going to do, I want to know everywhere it crosses the x-axis. So I'm going to go to second trace. I want to know my 0. So I'm going to go down to number 2, hit enter. It's going to ask for the left bound and right bound. So I need to go to the left side of the 0, which happens to be below because it's on the left side. And I'm going to hit enter. Go to the right side of this, of where it crosses the x-axis. So go on the other side, hit enter. Hit enter one more time, and it gives me a 0 of negative 2, which we already found, but this is how you can find it on the calculator. And now so we know that one of our zeros is negative 2. Go back to second trace. We need to find another 0, hit enter. So now it's going to ask for the left bound again. So I need to find this 0 right here where it crosses the x-axis. So the left bound on this case is going to be above the graph because it's on the left side. Hit enter. The right bound is below it because it's on the right-hand side of where it crosses. Hit enter. It asks for you to guess. Hit enter, and it gives you your answer, negative 1. Now I need to do it again. I want to find this 0. So I'm going to go second, trace. I need the 0 again. So now I need to toggle over Now, if this is where the 0 is, I need to go to the left-hand side, which is below it, hit enter. Now I need to go to the right-hand side of this, which is above it, hit enter. Hit enter one more time, and it gave us our third 0, which was 3. Real life connection. The height of a ball thrown by a child is given this formula. How far from the child does the ball strike the ground? Meaning, so if you have a child and they have a ball and they're throwing the ball in the air, at some point it is going to hit the ground. This is where it hits the ground. We want to know how far away, so basically, what is the X value of when it hits the ground? This means we are looking for a 0. So there's two ways you can do this. You can either set this equal to 0 and do synthetic division, or you can bring up your calculator. And if you go to y equals, clear out anything that you have. Now in this case, you need to hit parentheses 1 divided by 12 before you do your x squared. And then plus 2x plus 4, hit enter. Now if we were to graph this, if you notice, you cannot see where it comes down on the x-axis. Here it's a negative number. Well, the ball's not going to strike at a negative place, which means you got to figure out where over here is the x-axis. So here's what you do. If you hit zoom 3, so if you want to go to zoom out, go down to 3, hit enter again, it will zoom out for you, and now we can figure out where it crosses the x-axis. So we go to second, trace, we need our 0. So toggle over to find the left bound. Keep toggling. We need somewhere on the left-hand side, hit enter. Now we need to get somewhere on the right-hand side, hit enter one more time, and it gives us our answer. This will sometimes happen. 1 times e to the negative 12, it just means it is a very, 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 very tiny number. It's just going to be a guess. So your 0 is 25.856. 25.856. So we know that x equals 25.856, which means that it is going to travel almost 26 feet away from the child before it actually hits the ground.